When we look out into the cosmos, we like to think we're seeing the truth, right? But what if I told you that our entire view of the universe is fundamentally warped? Today, we're going to decode the cosmic illusions that are all around us, and you'll see how the biggest lies in the universe, well, they actually tell us its deepest secrets. Take a look at this incredible image from the Hubble Space Telescope. I mean, it looks like a smiling face in the cosmos, but almost everything about it is an illusion. That perfect arc of blue light? Yeah, it's not really there. But understanding why it appears this way is one of the most powerful tools we have for figuring out how the universe actually works. All right, so here's our game plan. We're going to start with the whole idea of our distorted universe. Then we'll get into a star's strange little wobble, gravity's giant lens, these things called footprints of the cosmos, and finally, we'll see how we put it all together to decode everything. So our journey really begins with a challenge to our own senses. What we see through a telescope, it's not just a pretty picture. It's a puzzle that needs to be solved. I mean, really think about that for a second. When you look up at a star, you assume you're seeing its true location. But from the very moment that starlight starts its journey towards your eye, it's being altered. It's being shifted and distorted by the very fabric of the cosmos itself. So our first illusion, it isn't caused by some distant, exotic object out in deep space. Nope, it's caused by us. The simple fact that we are hurtling through space creates a fundamental distortion in everything we see. For centuries, this completely baffled astronomers. They noticed that stars, over the course of a year, they didn't stay perfectly still. They appeared to trace these tiny little ellipses in the sky. And it wasn't parallax, the effect of distance. This was something else entirely. So what in the world was causing this celestial wobble? Well, the answer is something called the aberration of light. And what that really means is because the Earth is constantly moving, we're talking about 30 kilometers a second, we're basically catching starlight at a slight angle. Our own motion actually shifts the apparent position of everything we look at. Think of it this way. If you were just standing still in space, light from a star would come straight down at you. But since our planet is constantly on the move, we literally run into the light rays, and that makes them appear to come in at an angle. It's just like walking in the rain. Even if the rain is falling perfectly straight down, if you're walking forward, it feels like it's coming at you from an angle, right? And the faster you walk, the more angled it seems. Well, the exact same principle applies to starlight hitting our moving planet. And discovering this was a huge deal. James Bradley's work back in 1727 was one of the first physical proofs that the Earth really does orbit the sun, and it led to a surprisingly accurate early measurement of the speed of light. But, it wasn't until Albert Einstein came along in 1905 with his theory of special relativity that we finally got the full, correct explanation. Okay, so our own motion creates a little illusion. But what happens when the very fabric of space-time itself gets bent out of shape? Well, that leads to an even more profound, even more mind-bending distortion. This is what we call a gravitational lens. Einstein's theory of general relativity tells us that massive objects, they don't just pull on things with gravity, they literally warp the space and time around them. And just like a glass lens, this warped space can bend light that passes through it. Just look at this. It's called Einstein's cross. You're seeing 4 points of light, but it's not 4 different objects. No way. It's one single, distant quasar. The gravity of that galaxy right in the center has split the quasar's light into 4 distinct images. It's a perfect cosmic mirage. And hey, remember this picture? Well, now you know the secret. The 2 bright eyes are massive galaxies in the foreground. Their immense gravity has taken the light from a much more distant blue galaxy sitting directly behind them and bent it, stretched it into that perfect arc that we see as a smile. We call that an Einstein ring. And it's not just single galaxies. We're talking about entire clusters of galaxies, containing just unbelievable amounts of mass, acting as these giant lenses. It basically turns the sky into a cosmic funhouse mirror, stretching and smearing the light from everything behind it into these ghostly arcs and wild distorted shapes. So this illusion, it's actually one of the most powerful tools in astrophysics. Strong lensing, that gives us these spectacular, obvious arcs. Weak lensing, that's more subtle, but it lets us map out the location of invisible dark matter. And microlensing, which just causes a brief brightening, helps us find planets orbiting distant stars. So far, we've talked about light that's been shifted and light that's been bent. But we can also see things that are completely invisible, just by looking for the footprints they leave behind. I mean, the universe is just filled with these high-energy particles, cosmic rays, zipping through space at nearly the speed of light. They're way too small to see directly, so how do we even know they're there? Well, we look for the damage they cause. When one of these super-fast particles smashes right through a solid material, it leaves this tiny trail of destruction in its wake. These are called ion tracks. They're basically the microscopic fingerprints of invisible cosmic travelers. And these are real, physical trails of damage, just a few nanometers wide. It's incredible. By chemically etching the material, scientists can actually make these tiny tracks visible under a microscope and study them. And from that, they can learn about the particle that made it, its energy, its charge, what it even is. And this isn't just some abstract lab technique either. This exact technology was used on the helmets of the Apollo astronauts. By analyzing the little ion tracks left in their visors, scientists could measure the exact type and amount of cosmic radiation they were exposed to on their trip to the moon. Pretty cool, right? Seeing the unseen to keep people safe. So let's bring it all together. We have illusions of motion caused by us, illusions of space-time caused by gravity, and illusions of invisibility that we get around by searching for cosmic footprints. This right here is the art of astrophysics. You know, astrophysics is really the ultimate detective work. It's not just about figuring out where things are anymore. It's about using physics to figure out what things are and how they work. It's the art of turning cosmic illusions into real cosmic understanding. So what we first thought of as cosmic tricks, our own motion shifting the stars, gravity bending light, invisible particles leaving tiny tracks, they aren't flaws in our vision. They're actually the essential tools of the modern astronomer. They are the very techniques that allow us to decode the universe. We've learned to read the universe's bent light and its invisible footprints, but it just makes you wonder, right? As our tools get sharper and our understanding grows, what other deeper illusions are we still living with, just waiting to be discovered? What else is the cosmos hiding in plain sight?